Hey there, geometry. So in this lesson, we're connecting similarity and transformations. And in this actual example, in this task statement, we're talking about how not all rectangles are similar. Okay, um, not all figures are the same shape. Not everything is as it seems. So um, we're going to try to explain what's wrong with this attempt to dilate a square. So here I have a square and I'm attempting to dilate it and I'm not doing a very good job. So if I look, like if this is a square, that means that these are all congruent. And if I've dilated that square, then these should all be congruent. And they're obviously not. You could maybe say that, well, you can maybe say that, oh gosh, those are congruent, but these are not. Where you might even be able to say that, like, these are congruent, right? Okay. Let me erase all of that stuff. So what happened with this dilation? When I first looked at it, I thought to myself, well, they didn't draw rays through the other points. Like there's no ray drawn through the other corners. Like if I drew the ray through B, there it is. And I've got to do it again. Through C, then doesn't that mean that like this would be my new point? Because it went through B, so shouldn't it be there? That's my new corner, and that's my, like this would be my B prime and my C prime. Well, that doesn't give us, I can't even draw that. I don't even have right angles anymore, so that certainly didn't work. Okay, so icky, no, can't do that. So that wasn't the problem. Maybe it's because like they dilated AD to GH, but they forgot to dilate AB to GF. Okay, so these got dilated well. Okay, that was good, but those did not. All right, when you do a dilation, you have to dilate all of the segments the same amount. Okay, the angles are going to hold steady, which these angles did. They're all 90 degrees, but the segment lengths did not dilate. So if this was I'm almost out of colors here. So if, say, P to A was 1 unit, and then P to G was a double, so that's also 1 unit. So we went from 1 scale factor of 2. That means that AD AD was a measurement, and then I can't even read that now. GH was twice AD, and BC was a measurement, so EF was twice BC. But FH is not twice CD, and EG, I think that is not twice AB. So they didn't scale all the pieces and parts. Okay, if this probably makes better sense for it to be out there. So keep that line perpendicular. And there we would go. So this would be B prime, this would be C prime, and I bet all of those sides will be square with each other. All right, so a card sort, not so rigid transformations. Let's read through this. Your teacher will give you a set of cards. Sort the cards into categories of your choosing. Be prepared to explain the meaning of your categories. So in a Google Doc, I'm going to put all the cards, and you're going to number some category, and place the cards in there, and then a different category, and place whatever other cards in there. Okay, maybe there's another one. All right. Sort the cards in the category of choosing, be prepared. And then I'm going to assign you one card. And you're going to write a sequence of transformations to take one figure to another. All right? For all the cards that could include a dilation, what scale factors used to go from figure F to figure G? What scale factors used to go from G to F? All right? So you're going to do all of those on a Google Doc. And you can always message me if you need something, or write a comment on the Google Doc and I'll get notified that you have a comment. Either of those things work. All right? So I'm going to throw a Google Doc in Google Classroom and it'll be a great time. All right. So let's look at this one. Alphabet soup. So translation and dilation takes triangle ABC onto triangle FDE so that they are actually similar. Okay? ABC onto FDE. And notice we've named them in the correct order so that triangle ABC is similar. And that's what that symbol right there means. Similar to FDE. So first we did a translation by directed line segment BD. And then we did a dilation, center D. All right? So let's look at this one. Are the triangles similar? So we know that AB is parallel to QR, and AB is perpendicular to AE. No, AB is perpendicular to AD, and QR is perpendicular to QT. So I have parallel lines and perpendicular lines. And it looks that angle B is the same measurement as angle R, and angle E is the same measure of angle T. So write a sequence of transformations to take one triangle to another. So let's do, I'm going to go to red. I'm going to translate triangle ABE to triangle QRT by directed line segment AQ. Let's write it in the right order. So I'm going to do a translation of triangle ABE to QRT by directed line segment AQ. And then I can do a translation or a dilation. By what scale factor though? We're getting smaller, so I can take any of those measurements and put the smaller one over the bigger one. This is my scale factor. I took 6 over 15, and I'm going to simplify that. So they're both divisible by 3, so 2/3. Okay, so a scale factor of 2/3. That'll work. Did anyone see that I did my math wrong? 6 goes into there, 3 goes into 6 twice, 3 goes into 15 5 times. So that's my scale factor, 2/5, which is the same as 0.4. Cool? So we're good. That's our number 1. Confusing because I wrote 1 and 2 because there were 2 steps to it. Write a similarity statement about the 2 figures and explain how you know they are similar. I can say that triangle ABE is similar to triangle QRT because I have a sequence of transformations that takes one to another. But there's one more step I want to make sure I talk about. Let's write that down. Because a sequence of rigid motion and non-rigid, which is the dilation, takes one to another. Compare your statement with your partner statement. We didn't do that. Is there more than one correct way to write a similarity statement? Yes, I could say triangle EBA is similar to triangle TRQ. It doesn't matter as long as the corresponding angles are the congruent angles. All right, as long as E and T match, and A and Q match, and B and R match. It doesn't matter what order you put them in as long as they're in the corresponding orders from each triangle. All right. Oh, hold on. Usually I just have to stand up and then the lights come back on. For this little image, I just want to talk about JL is 2 times PR. Okay, so to go from JL to PR, I have a scale factor of 2. To go from this triangle to that triangle, I have a scale factor of 1/2. But all the angles are congruent. Not to each other, to their corresponding parts. All angles, let's say all corresponding angles are congruent. So I can say here that triangle JLK is similar to triangle PRQ. All right. What else do we want to? I think that's it. Yep, it doesn't matter which way you say it. All right. So that'll work for today, and we will talk to you for the next lesson.